Welcome to everyone, dear friends. Let me move on to the next bit of the topic is coordination compounds. Dear friends, today we have to know little concepts of some name of ligands and their chemical composition. Dear friends, we know there are three types of ligands: cationic ligands, anionic ligands, and neutral ligands in the last class. The cationic we have a very few examples. One is NO2 plus is a nitronium ion, and similarly NO is a component is a nitrogen. So many components which is comes under cationic ligands. But today we have quite familiar about these concepts because which helps for the IUPAC nomenclature of coordination compounds. Let us begin, friends. The type of anionic ligands and the corresponding names. Yes, if you use the compound is Br minus, generally we call it X minus. X stands for halogen. This halogen is pronounced as a ligand in coordination compounds is a halo. Similarly, the component if you use Br minus is pronounced as a bromido, F minus is a fluorido, Cl minus is a chlorido, and OH hydroxyl commonly the OH minus is carried out hydroxido, Cn cyanide is pronounced as a cyanido. Oxalate C2O4 minus 2 oxalate is oxalato, and carbonate CO3 minus 2 carbonato. These are the pronunciation of the ligands corresponding to these formulas. You keep yourself, yes, with a charge you keep a Br is minus 1, F is minus 1, Cl is minus 1, OH is minus 1, cyanide is minus 1, yes, oxalate is minus 2, carbonate is also minus 2. And similarly, the acetate CH3CO minus pronounced as acetato, and NO2 minus is nitrato. Yes, this is a little major part of these two ligands because they are comes under ambidentate ligand. NO2 is a nitrato, N it is a nitrogen coordination, and similarly ONO it is also minus, there is a nitrato, O this is an oxygen is a coordination. Similarly thiocyanate S sulfur is coordination, and NCS the nitrogen is coordination. This is the term to pronounce as acetato, nitrato N, nitrato O, thiocyanato S and thiocyanato N. These are the concept of anionic ligands. Similarly, the major part of our syllabus is neutral ligands. Quite familiar about the neutral ligand. I think all of you know ammonia is a Lewis base. The ammonia NH3 is pronounced as amine. Water H2O is pronounced as aqua. NO it's not no, it's NO is pronounced as a nitrosyl. CO, carbon monoxide, is pronounced as a carbonyl. It's a pyridine, is as usual pyridine. This is ethylene diamine. I think all of you know the symbolical representation is EN. Yes, ethylene diamine is pronounced as ethane 1,2 diamine. These are the major part of our different ligands. We keep practicing with their charges and the donation of lone pair of electrons to the central metal. With the help of these common ligands, can easy to calculate the oxidation state of central metal, friends. And dear friends, after the nomenclature naming of the ligands, we move on to the how to calculate the oxidation state of central metal. Keep yourself CM nothing but central metal atom or ion in a coordination complex. Let us begin, friends. We have a simple compound of our syllabus. CuNH3 4 times SO4. How to calculate the oxidation state of central metal? Very simple, friends. Yes, we know the charge of the ligands and some anions or ionic spheres. This is ionic spheres. Yes, there are two types of ionic spheres. One is cationic and anionic. Cation, this is a potassium and sodium, these are quite common, plus one charge. Similarly, SO4 sulfate is minus 2, carbonate if comes under this is a minus 2, halogens are comes under minus 1. These are the charge you remember which helps to calculation of oxidation state. Yes, friends, this is a square bracket you mentioned as a coordination sphere. Apart from the square bracket we call is an ionic sphere. After coordination sphere it is anionic sphere. Very simple how to calculate. We underline this copper, as copper is nothing but X. We have to find out plus Total number of ligands are 4. Ammonia is a neutral, the charge is 0. Yes, the net charge is becomes to 0. The component, yes, easy to know the sulfate. Sulfate is a minus 2, is equal to is a minus 2. Yes, the whole charge of the component which is easily available and our syllabus. Yes, based on this you can easily to calculate the whole charge of the complex is minus 2, this is a 0. The net whole charge of the complex is becomes to the 0, that's why it's minus 2, the copper is plus 2. Obviously, the whole charge of this complex is becomes to plus 2. The net whole charge of the complex is becomes to plus 2. How to know? Copper is X, ammonia is 4 into 0, this becomes 2, sulfate is minus 2. Yes, the whole term X, automatically this becomes to 0 is equal to minus 2, X is equal to minus 2. Yes, the net charge is becomes to complete the component, the net charge of the complex is comes under to the copper plus 2. Very simply you can easy to calculate. And similarly friends, this is K3 Fe Cn 6 times. Yes, we know the potassium is plus 3, the component is becomes to plus 3. Yes, this is a plus 3. Iron we can find out, and cyanide is each charge is a minus, this is component is becomes to the X, they becomes to the 6 into minus 1, and this is a minus 6. Minus 6 plus 3, the charge is becomes to the plus 3, the total net charge is becomes to 0. Yes, a closed ionic sphere, 6 minus 3 is becomes to the minus 3. Yes, very simple calculation of the oxidation state. This is the oxidation state of the central metal. Yes, the plus 3 is a component which is available to the net whole charge of the complex. Net whole charge of the complex. Yes, based on this, you can easy to calculate the oxidation state of every central metal in our syllabus. If you consider another example, K4 Fe Cn 6 times. Directly, this potassium is plus 4, cyanide is minus 6, each carries minus 1. Yes, minus 6, that becomes to the 0, automatically they becomes to the plus 2. And close this ionic sphere, minus 6 plus 2, the net charge is becomes to the minus 4. This is your charge of the complex. Similarly, NiCO 4 times. It is only the coordination sphere. Keep yourself, carbonyl is a neutral ligand is 0. If it's 0, the nickel is becomes to 0. The net whole charge is becomes to the 0. This is also one type of neutral complex. Yes, if you use another one, FeCO 5 times, pentacarbonyl iron. Yes friends, carbonyl is 0, iron is 0, net charge is 0. Yes, the oxidation state of the copper is plus 2, oxidation state of iron is plus 3, oxidation state of iron is plus 2, here nickel 0 and iron 0. Similarly, you can easy to calculate so many complex in our syllabus based on the component. You can easy to calculate of our syllabus. Yes, I can use Na3 Fe OX thrice. This is also one example. Yes, ox means oxalato. Yes, sodium is 3, automatically this is a plus 3. Oxalate is a bidentate, each carries minus 2. Minus 2 into 3 becomes to minus 6. Okay, the net charge of the complex is 0. That's why minus 6 plus 3, they automatically plus 3. This will close here, minus 3 and plus 3, this is the minus 3. Can easy to calculate a kind of example. ಬೇಕಾದ ಕೊಟ್ಲಿ ನೀವು ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಬರ್ತದೆ. ಸೊ ಇದನ್ನು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ತಾ ಹೋಗ್ರಿ ಮಕ್ಕಳೇ. ಯು ಕ್ಯಾನ್ ಈಸಿ ಟು ಅರ್ನ್ 2 marks ಫಾರ್ ಯುವರ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್. ಯುವರ್ ಕ್ಯಾಲ್ಕುಲೇಷನಲ್ಲಿ ನಾವು ಈಸಿಯಾಗಿ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೋದು. ಯಾವುದೇ ಒಂದು ಕಾಂಪ್ಲೆಕ್ಸ್ ಕೊಟ್ಟರೆ ಯು ಕ್ಯಾನ್ ಈಸಿಲಿ ಮೆನ್ಷನ್. ಓಕೆ, ಬರ್ಬೋದಲ್ಲ? ಸೊ ದಿಸ್ ಈಸ್ ದ ಮೇಜರ್ ಪಾರ್ಟ್ to the calculate the oxidation state of central metal. Okay, thank you so much dear friends, and then we move on to the complex ion and type of